Hello everyone and welcome. Today we're going to be working with curves in geometry nodes and simulations as well. We're going to create something like an effect that looks fun and, well, is more of a basic kind of tutorial. Now hold up 1 second, about 86% of you guys aren't subscribed yet. So if you do like this video, if you learn something, leave a like, comment, subscribe. Any one of these would help me out a lot. Enjoy the video. So let's actually delete our cube. Delete. Delete. Shift A, let's add a curve and a bezier. Let's go into edit mode, press A, delete vertices, because I want to be drawing my own curve, right? So just pick the draw curve icon and draw whatever you feel like. For example, this. And now let's open up a new window, set to geometry node editor and hit new, press N to hide your properties. Here we are in the geometry nodes window. Let me crank this down a bit and zoom in here. So how do we start this off? We have a curve, right? So we don't have to worry about adding a curve, but more modifying the curve. Now each curve that we spawn consists of points, and how the curve looks depends on the type of spline it is and about the handle types, right? So if we go into the geometry nodes here, Shift A, and we can actually set spline type there, and Shift A, set handle type, right? And this says a lot about our curve. Now this is a bezier curve, right? So we have a bezier, but we can also set this to NURBS or poly and catmull as well. So we have a bezier curve, and we can set the handle type as well. If we would set this to, for example, to be a vector, it would look like a poly curve, right? So let's just connect this and see. Here we go. We actually now have about 4 or 5 points in this curve, which is why it looks so weird. But if we set that to auto, it is going to make that beautiful and smooth, right? So that means that we don't have a lot of points in our curve initially, okay? And that is something that you just need to know. If you have a bezier curve, it may look high res, but in geometry nodes you may not be able to access all that data yet. Okay, so what we have to do is we can actually delete this. We got a bezier curve. We can hit Shift A and find a resample curve. Now the resample curve is going to just divide our curves into individual points along that curve, and we can actually set a resolution ourselves now. We can also set this to length, which means that it's going to have a new point every pretty much length increment, 0.1 meters for example. The higher you make this, the low poly it's going to get. The lower you set this, the more detailed, right? So it's the distance between points pretty much. And that also means that if we add, for example, a trim curve in front of that, the resolution will always stay the same no matter how short or long your curve is. And that is something very interesting. So let's just keep this like that for now, and let's start worrying about what we actually want to do. So what I want to do is go into a simulation zone, and the reason why is because I want to pretty much spawn points along this curve that are going to be behaving in a fun way, moving out or whatever, doing something fun. So to do that, let's move this to the right and hit Shift A, simulation zone, and let's just connect everything up here and there. The simulation zone, for whom is not familiar with it, just goes over everything that's happening inside of this simulation zone every frame, right? So everything you do in here will be iterated every frame. So that means that we can do fun stuff with it, like move particles, for example, okay? Now to do that, I want to start off with points instead of the curve. The curve is just our guide curve, right? So we want to have actual points. So we can hit Shift A and find a curve to points. There we go. Now here as well, we basically resample our curve, right? So we can actually Control X the resample curve and set this to length instead, and we'll end up with the same kind of resampling as we had before. Now to actually make this a bit cleaner, let's find Shift A and set point radius, which is basically going to allow us to just make that a bit more small, okay? So this looks quite alright. Let's move them a bit closer. Here we go. And now we've got points that are moving into a simulation zone. Quite beautiful. So if we now drag this to the left, we can actually store an initial velocity of our points. Let's say I want to move our points in the direction of the curve, right? We want to set a velocity that they start off with right from the start. So to do that, we can hit Shift A and store a named attribute. Remember, anything we do before the simulation goes in with a starting value, right? So let's say we want a velocity of every point, and we want them to have an initial velocity moving out or more along the curve. We can set that up right before the simulation zone and adjust it, alter it in the simulation zone. So to do that, we can have a vector here, because a vector is usually what you do for a velocity, because it is in 3D space, anything 3D related, a position in space, a direction in space, you'll pick a vector for. And we can set our vector name to be vel, right, velocity. And our value is actually going to be related to the tangent of the curve. Now, what is the tangent of a curve, you ask? Well, the curve has a direction, right? This is the direction of the curve, start to end, and the position, or the tangent, sorry, is basically the direction of the point on the curve, right? So let's say this point has a tangent of that. This point follows the curve in that direction, this one in that direction, this one there, and you get what I mean, right? So that is the tangent of a curve. You also have a normal, which is of course 90 degrees angled on that tangent. Okay, beautiful. So we want the tangent of a curve to be the initial velocity. So let's drag that into the velocity. There we go. And now if we drag our window to the bottom and set this to be spreadsheet, we can actually open up the points here and see what the velocity is for each point, right? So this spreadsheet editor is very useful to see what we're doing. We're now storing a velocity for each point that we have, points 0 to 42, and they have a specific velocity direction vector stored. So what can we do with that, you ask? Well, we can, in our simulation zone, hit Shift A and set a position, and we can actually give an offset that is related to our velocity. So Shift A, named attribute, and we can now name this vector and vel. There we go. Connect that to the offset, and there we go. So now each frame we're gonna have an offset in that normal direction, or tangent direction, sorry. If this is too much, right, of a velocity, if it's too strong, we can hit Shift A, find a vector math, swipe that in here, scale the entire velocity down to like 0.05, right? So if we now play this, they're going to be actually moving out in that direction of the curve, right? Isn't that cool? And that means that we now already have a nice simulation set up, right? Now, if you want these points to go slower, for example, the longer they are alive, okay, we can actually store our velocity value once again in the simulation zone. Now, this is where it may get a little bit complicated, okay? And because we are storing it here, why would we store it here again? Well, that is because we can actually change a value based on the frame amount and based on what's happening in here as well. So this gives us the initial velocity, but let's say we want to subtract a velocity every frame to make it move smaller or slower and slower and slower, the longer it is alive, right? We can actually do the same thing in here. So store velocity here. There we go. And velocity is going to be velocity. But Shift A vector math. No, Shift A vector math. What we're going to do is manipulate it to subtract, for example, a specific value. Or we can actually set this to scaling because we already have a directional vector that we just want to slow down. We can just set this to, for example, 0.95. And that means it's going to scale 0.05 every frame it is alive, right? And then we don't, yeah, we're already connecting our velocity here. It's going to update the next frame it is going to be scaled down by 0.05. So if we now play this, it's going to be slower and slower the longer it is alive, pretty much, right? It's giving us more of a sense of an object that is getting slowed down in water, for example, right? A bullet going into water starts slow, and it's going to slow down and fall down, right? So if we want to mimic that effect, for example, I'm not sure why my face suddenly got big. Let's crank that down. Hello. Back we go into the corner of our screen. Beautiful. We can actually now give it a little bit of a vertical velocity as well. All right. So let's do that too. So I want the vertical velocity to become bigger and bigger every frame, because that is how gravity works, right? We've got an acceleration in the downwards direction, usually to the center of the earth, pretty much. So we can do that. So let's move this to the left here. Shift A, vector math, and hello, vector math. And after scaling, let's say we want to subtract a value as well. And I want to subtract only a z value of, let's say, 0.02. Let's see how that goes. Right, and now we actually get a bit of that falling motion as well. Quite interesting. So now we actually are starting to have something fun. And what I want to do as well is that after a specific time, I want there to be some random motion. If we're really going with the watery effect, I want that to be a bit more wobbly as well, right? If a bullet enters, for example, water, it goes fast and then it slows down, and usually there's some kind of a little wobble, I suppose. So we can actually do that as well. So what we can do, if I want this to happen after a specific time a particle is alive, we first need to store a value that is actually going to give us the time of a particle, the age of a particle. So Shift A, find a store named attribute right at the start. We can set this as a float, but we can also set this an integer. And because we are working with a simulation that is based on the scene frame, we can work in integers because we have, well, each iteration is going to be 1, which means that each iteration, the age is going to increase by 1, okay? So we can then name this to be age, and the value, drag that out, it's going to be a named attribute of age. Remember, when we want to have something happening every iteration, we need to start with a store named attribute set to a value, right? And then we want to have something happen to that value every frame as well. So each frame something happens and is being stored again. And then with a new value, something is happening and it's stored again. The next frame we have a new value, something's happening in between here, and it's stored again. I hope that makes sense. So what we can do is find a math node, and we can just add 1 every frame. That means that at frame 0, it's going to be 0. Next iteration, we're going to have 0 plus 1, stored as 1. Next frame is going to be 1. Adding 1 is 2, storing 2, and so forth, right? So that is beautiful. So remember that. Now, if we want, after a specific time, or the farther they go, the stronger they wobble, for example, we need to set up first a motion that makes it wobble. And the easiest thing, of course, is a noise texture, okay? So hit Shift A, find a noise texture, and here we go. Now we can use the color as a vector, right? A vector is basically a color input as well, basically. But it's not exactly the same, but it can actually be used for a vector offset, okay? So how do we do that? Well, let's move this a bit to the left, and actually let's press Ctrl J to group this, and let's name this frame, select the frame, and name this to be, we can name this velocity reduction plus gravity, I suppose. And then we are going to use that, right? And actually I'm going to duplicate my velocity, move that to the right, press Alt P to disconnect it from the frame. And I'm just going to connect that up here because I am getting tired of that string going through everything. So I'm just going to duplicate the velocity. It's the same setup, just with a extra named attribute, okay? So if I want to add a wobbly motion, what we can do is duplicate our subtract node here and set that to add, and press Alt P to just get that out of that frame because we're still defining that, we can actually add a noise texture as a vector here. Okay, and if I'm now going to play this, it's going to be incredibly crazy because one, the reason we're using a noise texture is because it gives us a random offset, but it's also going to give us a diagonal motion. Every time you use a noise texture as an offset kind of input or a vector input, it's going to shift your direction to the top right like that. And that means that it's just like a thing you need to remember, vector math, subtract 0.5 every time you connect a noise texture to a vector input pretty much. Okay, Alt P, disconnect that from the frame. So now let's also scale that. So duplicate your subtract, set this to scale and set it to like 0.05. And now you can see that they are being noisy and the noise pattern, well, it's just random pretty much, right? So they're moving in a random way. Now I want this to happen after a specific time, which means that I'm okay with the scale it follows, but it needs to happen at a later stage. And this means that we can just add a new scale element here. And let's just move this one out of the way. And this scale element, I want to be dependent on the age. So let's duplicate our named attribute age here, put it there, and connect that attribute to the scale. Now, a scale that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 10 is going to be way too much to scale this up in. I want to start this at 0, which is fine, but I want this to end up at like 1 and stay at 1 as well. And that means that we can actually do a map range here. And from, well, actually, let's not do a map range, but a math node. Let's set this to multiply. And let's multiply this with 0.03, which means that it's just going to be scaling with 0.03 every frame. And that's just going to make that noise strength stronger the more they are alive, right? The older they are pretty much. So let's see how that looks. In the start there's not a lot, but then it's get more and more and more and more and more. All right, isn't that beautiful? Now it almost looks like there's let's say there's like flies that are being expelled from a branch or something and then flying away, right? So if we would make this motion of the gravity here to be minus 0.02 or just change this to add. So what else can we do with this? So it's not water anymore, obviously. And let's say we want these to be particles that are, for example, spawning away from a branch in a fantasy world where particles are located on branches and they just, well, fly out a little bit like fireflies. I don't know. We can actually give this a nice particle object. So Shift A, instance on points. And we can, for example, set the instance to be an icosphere, let's say, with a lower radius. And we can actually make the subdivisions to be like 2. I think that will be fine. And let's Shift A, shade smooth as well. There we go. Now, when we want to add a material, I am going to actually go to my shader editor and hit new here, because for some reason lately when I go to my material tab here, I'm crashing. So I'm just going to hit new here, and let's call this material particle and set our material here as well. So we can hit Shift A, set the material, and set this to be particle. Can't we? There we go. I thought I was crashing again. I was almost clicking away. And now if we actually set our cycles engine to GPU, we move here to render, and let's hide all of our own things. And let's set this to be black because we want to work with light, right? And we can now set our emission to be, for example, a little bit higher, like 5. And if we play this now, we get some particles spawning away and flying into the air. Quite interesting. Now, what I want this to look like though is particles on, for example, a branch. Okay, so what I'm gonna do is I'm gonna tweak these settings, but first we're gonna work on this material, and because I also want to have them die off with age a bit, right? So perhaps make them scale down and also fade the color out. So how do we do that? We have a scaling value, of course, in the instances, and we have an age value that we store here, right? So just Shift A, add a named attribute, and name this age. And we can use this to scale it down. All right, so what I want to do is I want to scale everything down smaller and smaller and smaller, which means that I'm just going to hit Shift A and find a value of 1. So start with a scale of 1, and I'm going to find a math, and let's actually divide this by the age. Right, so every time the age becomes bigger, it scales down. So if you play it right now, it's going to be disappearing quite quickly. So I want to divide this by the age, but I want this to map different. So map range, find a map range. Now I want this to be from 0 to 1, to, well, let's say 0 to like 25. Let's say we want to scale this down in 30 frames, 30. Then I want my value, my age from 0 to frame 30 to become my value from 1 to, let's say, dividing by 3, right? And the reason I'm doing this is I don't want my age to ever divide by 0, right? Which it would do if we start at frame 0 and we don't add a map range. So now whenever our value is 0, it's going to be mapped to 1, which means dividing by 1 is 1. And whenever my frame is 30, it will be dividing by 3, which will make my particle smaller but not completely disappear. Okay, so if I now play this, you can see what that does. They will become smaller, but they will stay around for a little while. Now we can do the same thing for the emission strength, okay? Let's say we have a stored value H. We can access that in the materials with Shift A and find an attribute. It's not a named attribute, but just attribute there. And we can actually set this to be H as well. And we can use the H to color, strength here. Now the reason this is not working right away, is because we're actually working with an instance right here and not so much with a point, right? So we can switch it over to an instancer and right away it's going to be working, right? So I don't want my my emission to increase but decrease. So Shift A, we can find another map range, why not? And when my H is 0, when we have 0 H, I want this to be the strongest, let's say 10. And when my age is 30 or 50, let's say, I want this to be 0. So now it's going to be counting back in strength from 10 to 0 as well. Okay, beautiful, beautiful, beautiful. So let's delete our light point in the scene and just show this as our particles, as our beautiful points that are spawning away from that branch. Isn't that quite cool already? Now, what we can even do is define the color, for example, as well, right? And that is a fun one too. I will show you that. So we can, for example, use the same H here to be a color. And what this means is that we can actually just use a similar map range, duplicate that for the H, right? So let's connect this to our value. And I want this from 0 to 50 to go from 0 to 1. And this 0 to 1 value we can drag out to a mixed color, and that can control the factor. Right, so at frame 0, we're going to have a factor of 0, and frame 50, we're going to have a value of 1. And at 0, it will have the first color. Let's say we want more of like a pinkish. And at the dying point, we want this to be more cyan blue. We can make this happen in the emission color here. Right, it's going to start off as a nice pink color, and the more it dies off, the bluer it's going to be getting. All right, now perhaps our strength of 10 is a bit much. Let's set this to 5. Then we get more of that color. You can see it's actually getting blue, right? And maybe I want this to happen earlier, like 25. That is quite beautiful, isn't it? All right, so that is already looking quite interesting. Now, what I want to change as well is perhaps a bit of randomization, okay, in scaling. I think that would add a lot here as well. So to do that, it's very easy. We can actually multiply our initial value for the scale, this. Let's find a math node, multiply this with a random value. Drag that out, random value, ranging from 0.4 to 1.4, for example, right? Or maybe even 0.3. And that is looking quite interesting, right? So now they're going to be moving out and scattering quite beautifully away in our space. Now, the fun part is we can add as many particles as we want, right? Because we resample our curve to points here. We can add way more points like that and actually make this look even more interesting, right? And that way it looks way more like something like a curve dissipating pretty much, right? Isn't that a cool kind of effect already? I like that a lot. Okay, so let's actually set this up for rendering perhaps, and you can see that if we rotate, for example, our curve in edit mode, it's going to rotate with it, and it's going to follow the same kind of geometry node setup. And that means that you can now, for example, delete your curve, and let's draw, for example, well, we can draw whatever. Let's draw a heart, for example, like that. Beautiful heart. If we now play this, you can see we follow the same effect for that heart pretty much, right? You can do that for whatever. You can add a nice kind of arrow through that heart, right? Beautiful arrow. And this is all going to be dissipating quite beautifully into thin air, right? So that is pretty much how you work with curves and values you store from these curves to make nice motions and stuff. So let's actually set up a nice render now. I'm going to press Ctrl Alt Numpad 0 to get my camera into a cool frame pretty much. Let's make it look. Hello, can I rotate this? I'm rotating my 3D cursor still. Set this back to medium point and we should be golden. Set this to global as well. There we go. Something like that. You can Ctrl B around your frame to see what it looks like. Quite interesting. And that's a nice dissipation effect, I suppose. Now, if you want some blooming going on, of course, you want blooming. And if we are in Eevee, we could do that. But in Cycles, we can do it as well in the Compositing tab, Compositor. And we can hit Use Nodes. And then we can, in between here, find a Glare node. Glare. And we can actually glare our images. And if we want to show this in camera, we can click on the Render tab and hit Compositor Always, right? Now we can set this to Fog Glow. It's in my opinion a bit better in this case. Set to High. And the threshold, we'll just play around with that, right? Just how much of that glow you actually want. And you can see your particles are dissipating quite beautifully, right? Nice. Now I'm gonna delete my curve and let's draw something more beautiful, like a hill kind of that. Beautiful hill. And that dissipates quite cool. Maybe I should draw it at the center in this case. A hill that goes up and down like this, like that, like this, like that, like this. Perhaps, and we play that, and that's quite cool. That is quite a cool effect, I suppose. I'm gonna do my entire curve a bit more to the left. Like that. Just so the points will move a bit more there. Amazing. So let's take this one step further, and that is if we actually do have a surface area, for example, the branch, we can work that as well. So let's find our initial curve here, and we trim that here. So let's drag this out to a resample curve, and let's set this to be length as well, and let's set this to like 0.05. And then we can actually, in the end, find a join geometry, and we can connect this here, move it to the right, we can join that back up here. There we go. And find Shift A curve to mesh, and profile curve is going to be curve circle. There we go. Now you can't see what's happening because the points are inside our mesh, right? So let's disconnect, or let's go back to solid view for a sec, and let's reduce the radius of our curve circle like that. Amazing. And let's find Shift A set spline, no, set curve radius. Set curve radius right there. And let's set the radius to be a spline parameter. Hello, drag this out to a spline parameter. And let's swap that around. Shift A, map range from 0 to 1 to 1 to 0. Like that. And if we now go to rendered, we actually get a pretty cool look, I suppose, of particles that are moving out of that initial curve shape, right? I'm not sure what I'm doing, but it looks quite fun. So let's hit Shift A and find a set material here as well. Let's go to the shader editor and let's open up the new material here and set this to be that material. Rename it to curve with caps for some reason, curve. Let's just decrease the roughness and increase the metallicness. And that usually gets a quite cool look if we got actual particles and stuff. As you can see, it's quite cool. And let's actually add a bit of a background as well. It's completely black. I don't quite like that. So let's hit Shift A, mesh plane, RY90. Let's move this back a bit, scale it up, and just make this look a bit more premium, I suppose. Right, this already looks more premium. If we now play this, we are starting pinkish, and we play this, and it gets more kind of particly as we go on, and they will dissipate beautifully. If you want to have some more fun, just draw some side branches out of your original curve like that. Like this, and like that. Draw some sub curves like this and like that. Draw one more there. Beautiful. Someone there perhaps. And let's draw one more, you know, for good fun. And let's draw a nice little kind of thingy like that. And let's play that, right? Pew. Isn't that cool? And now the fun part comes when we really start working with more depth, right? So let's say I'm going to move my camera to be closer to my object. Can we get this closer? Hello. If I get this closer to my object, and let's rotate this around a bit more. If I get this closer like this, perhaps. And if we now go to rendered view, and if we now actually get a bit more creative with how we place this, we can actually add a little bit of depth of field to our camera, depth of field. And let's crank the f-stop down a tiny bit. Like that. And then we set our distance to be correlating to how far away this is, right? We can set our distance to be, let's go from 0. Let's crank this up until we got something in focus. Preferably particles. There we go. That's looking cool. If we now play this, right, the particles are going to be moving out of focus a bit more. Let's actually move closer to the particles. You can see me struggling because I like depth of field a lot when we work with particles. Right, something like that. Let's see. We start like this, we play it, and we get fancy results. Let's even crank our f-stop down more. See? That's what I'm talking about. Let's move this more like that. Play this. And our particles be dissipating beautifully. Amazing. Even bigger, perhaps. I like that a lot. Let's go back. Play that. We got focus point right there. We can even crank this a bit closer, perhaps. So our focus comes more to the particles in our vision. For example, like that. And we play that. You can see we get quite a nice effect of particles dissipating. Isn't that beautiful? So play around with that. Get your settings to be how you want it to be. Draw some more curves. Like I said, you can never have too much curves, guys. Never. Especially not when you're working with depth of field. You just want everything to be filled beautifully, just like that. You want some crazy stuff going on. Make it happen. Really make it happen. Let's move our plane a bit more back. I feel like it's intersecting. There we go. If I now play this, we get way more depth and coolness going on. And I like that a lot. So if you like this, please leave a like, a comment, subscribe. I would enjoy any one of this. And I'll see you in the next one. Cheers.